Dear friends, architects, engineers, and consultants, and other students, uh, in this series of smoke control systems, we'll be dealing car parking and large tunnels. The smoke control is mandatory as per National Building Code 2016. The smoke control system for covered basement parkings has two different phases. One is as it was being done traditionally previously. Traditional mechanical extract systems use sheet metal ducting to transport the fumes or smoke being extracted to external atmosphere. The ducts must be evenly distributed around the car park and also drop to low level to provide the low level extract points. Accommodating large duct can be problematic due to low headroom in most car parks, and low level duct can be subject to damage from vehicle also. Friends, this particular slide shows a typical diagram of ducting system for smoke extraction system for car park. Friends, we are discussing demerits of ducted smoke control system, that is the conventional smoke control system. The main issues relating to ducted mechanical extract system which often cause problem for designer are: one, the ductwork runs underneath the ceiling, reducing the already restricted height normally available. Second, downstand beams require the ducting to be set down below them, thus diminishing the height even further. Third, low level extract points are required, often needing protective barrier to surround them, and these take up valuable floor space also. This happens due to movement of cars. The fourth is the ductwork gives the car park a cluttered look and can interfere with the CCTV coverage and lighting arrangements. Friends, this particular diagram shows sectional elevation of a mechanical ventilation system using a ducted smoke clearance system. In this, there are two different ways of collecting the smoke. One is 50% low level extract and another is 50% high level extract system. Friends, apart from the conventional system, it was in 1990 to 2000 a different type of system was developed which have now currently two different versions. One version is known as jet fans. Other names for this are jet thrust, jet vent, or impulse fan. The third one is induction systems, induction fans. We'll discuss both these systems, jet fans and induction fans. The jet fan thrust, jet thrust, jet vent, or impulse fan are the name of same basic system developed for car parking in Britain and then further developed in Netherlands. Jet systems originated around 1990 to 2000 period and have become increasingly popular as they can overcome many of the problems associated with the sheet metal ductwork. In the diagram, you can see that due to fire happening in the car park here, this is dealt with by this jet system. These are linear cylindrical fans approximately 1 to 2 meter size and diameter may vary from 300 to 600 mm. In this particular case, there are four such systems are provided: 1, 2, 3, and 4. Friends, this shows a schematic diagram of smoke purging system. In suppose your cars are parked in two different levels, first just below the ground floor and second below this first one. If the installation is more than one basement of building, then the smoke has to be purged. The diagram on left hand side shows fresh air entry from right hand side of the building and smoke being purged from left hand side. If the discharge here is not injurious to surroundings. So this system collects at different level, this down level, upper level, down level and upper level of two different floors. Smoke is collected and purged into atmosphere. The jet fans employed for smoke purging or smoke extraction can be of two different type: axial flow type and shown on the left hand side, and centrifugal or radial flow type on the right hand side. An axial flow fan mounted within an inlet and outlet cylindrical silencer tested as a complete unit. Jet fans can provide up to 50 newtons of thrust, suitable for most small to medium sized car park fans. In axial impeller, the water enters axially. It enters like this axially and get discharge also axially. Whereas in the centrifugal impeller, it enters axially, that is from like this or this, and get discharge radially, that is in centrifugal system here. A centrifugal with radial impeller fan with an air inlet positioned beneath the body of the fan and discharging through a reduced side opening. Induction fan can provide up to 100 Newton of thrust. Careful coordination is required if a sprinkler is used, suitable for medium to large car park. Benefit can be achieved from the greater coverage area. Attenuation is not provided on induction fan. Friend, remember we are discussing induction fans here. On the left hand side of this diagram, pictorial diagram, I have shown a jet fan of average size. This size may be 1 to 2 meters and diameter can be from 355 mm to 600 mm as detailed in the next slide. This can generate up to 80 Newton of thrust in different sizes. What average size can go up to 50 newtons. Friends, as discussed previously, there are three types of smoke extraction systems, of which one is conventional, the second one is induction type. Induction type we'll discuss little late, whereas we are currently discussing the third type known as jet fan or impulse fan. They can vary in diameter from 300 mm to 600 mm, and their length can vary from 700 to 900 mm in case of the lowest diameter size to 1500 to 1800 mm in case of the largest size. And the thrust produced varies from 15 to 80 to 120 newtons. Use-wise, the smallest fan is used in small basements with low ceiling and CO control. The other size 355 mm is used for medium parking areas. 400 is the standard enclosed car park. 450 mm is smoke control in large basements. 500 is large response high smoke load. And the biggest size is used for very large car park in high HRR fire design. So remember, on the top, this cylindrical jet fan is shown here. In another diagram on the right hand side, it is shown it here. Friends, now we will tell you how the jet fan work. Jet fan for smoke extraction. Jet fans were developed for ventilating tunnels and work by propelling a small jet of air at extremely high velocity, which causes surrounding air to be entrained and in confined spaces like a tunnel or car park can be used to move a large volume of gas. Uh, the jet fans were developed in tunnel ventilation for in Switzerland first, and then for car park they were developed in Britain and other countries later on. In car park, jet fans are used to replace the ductwork and to drive the fumes of smoke towards the extract fans to keep pollution within acceptable level and to clear smoke. Each jet impulse or induction fan has a characteristic thrust which designers use to position fans in car park to ensure relatively even distribution of air. This thrust we have already discussed in the previous slides. Dear friends, the impulse or jet ventilation system pushes the air through the car park towards a single extract point rather than pulling it to multiple extract points as a ducted mechanical extraction system may do. They provide greater flexibility and effectiveness. Impulse ventilation system comprise a series of fans located under the ceiling which generate thrust like a jet engine and add momentum to the air. Using a small fan at high velocity results in a large air movement at low velocity as the jet of air spreads out. A general air flow is created towards pre-designed extract points, moving smoke and fumes with it. Where impulse fans are used, they are located over the roadways in a layout engineered to ensure there is no area where it would be possible for fumes to build up due to lack of air movement. In most car parks, use a single extract point is required, located as far as possible from the main air inlet opening. Friends, we were discussing the working of jet or impulse type of system for extracting smoke. For this system requires an addressable fire detection system also, so that the site of the fire can be pinpointed and the system starts working from that particular point. A control system then starts only the selected impulse and extract fans to control the direction of the smoke and provide clear air in the designed part of the car park. The number and location of fans are carefully chosen to match the system design requirements and to ensure that there are no dead spots for fumes and smoke to stagnate and collect. The first two fan sizes are available, 315 and 400 mm diameter with an overall depth of 335 mm and 365 mm respectively. The thrust generated is up to 80 newtons. Third point is unidirectional or truly reversible or additional design flexibility. Fourth, two speed or single speed with potential for inverter control, continuous operation for 1 hour at 300 degrees Celsius. Friends, at last we are discussing induction or cyclone type fan systems. These systems have come little later than the earlier jet or impulse type of fans. Cyclone type reduces level of polluted air during day-to-day use and assists with the extraction of a smoke in the event of fire, directing polluted air and smoke towards the extract positions in a car park or underground service area. Using the same principle as impulse ventilators, induction fans are slimmer and potentially more powerful, thus reducing the number of units required. Impulse fans are generally limited to a thrust of about 50 Newton as they otherwise become physically too large for the constricted space available in the car park. Induction fans have thrust up to around 100 newtons. The floor area ventilated per fan is thus significantly greater, equating to a requirement of fewer units. However, in contrast to impulse fan, induction fans cannot generally be made reversible. The bottom portion of this slide shows a cyclone fan or induction fan as it is more popularly known. A centrifugal fan with an air inlet positioned beneath the body of the fan and discharging through a reduced sized opening. Induction fan can provide up to 100 Newton of thrust. Careful coordination is required if a sprinkler system is used. Suitable for medium to large car parks, benefit can be achieved from the greater coverage area. Attenuation is not provided on an induction system. This photograph I have taken somewhere in Dubai car parking system. In Dubai, uh, very large car parking systems are existing. The picture on left hand side of this slide shows an induction fan provided in basement car parking of Ferrari World near Abu Dhabi, UAE. It is about 30 kilometers away. I've seen this system. I've personally gone there and seen this system. Friends, this slide compares the two impulse and induction type of fans. Induction fans are shorter and slimmer than impulse fan, allowing a reduced excavation cost and lower car park height. They are also particularly suitable for effective ventilation over downstand beams or close together as they can more easily be located between them without compromising their performance. Slimline design is available, that is only with diameter 3, 308 mm or 250 mm overall with overall depth. Impulse fans are generally limited to a thrust of around 50 Newton as they otherwise become physically too large for the constricted space available in a car park. Induction fans have thrust up to around 100 newtons. The floor area ventilated per fan is thus significantly greater, equating to a requirement of fewer units. However, in contrast to impulse fans, induction fans cannot generally be made reversible. There are some more advantages in space to space saving benefit. Jet fans have other advantage over traditional ducted system, that is energy saving. Jet fan systems are often combined with CO detection to initiate them for CO control, and these can ensure that fans are precisely controlled to dilute pollution without fans running unnecessarily with a large potential energy saving. Jet fans make man extract fans are relatively smaller and for CO2 control run at lower cost than a traditional system. The noise generated is considerably lower. Low cost jet fan systems cost less than a comparable ducted system. So thanks, my dear students, engineers, consultants and architects for going through this series of um, smoke ventilation system. Thanks once again.